Hello. So let's solve today's problem. Find triplets with zero sum. And in this problem, all we have to check is there exists any triplet which sums up to zero. So for example, if we look at the very first test case, we have suppose 0, -1, 1, 2, and -3. Suppose we have array elements like this. So what we have to do is to check if we have there exists any triplet which sums up to zero. So for example, if we take these three, we get to see the sum of these three elements is zero, right? So we return simply true. But if it was this case, suppose if it was -3, 0, 2, 1, and -1. So it would have been difficult for us to determine where is the which elements would sum up to zero, right? So what we have done is suppose we have picked very first element, for example, this -3, we have picked and searched for the sum of the other two elements if it neutralizes this element, right? So what I'm trying to say is we simply look up for the number which eliminates this -3, which means we look for a positive value, which is 3, which will neutralize our negative number to 0, right? So if we have found that, we would return 1. Otherwise, we iterate, we move on to the next number, and we keep on doing that till our we go out of the list. Right? So what I'm trying to say is suppose we had -3, 0, 1, 2, and -1. So first we would have picked this element and we would have placed our low pointer, or you can say J pointer, at here and K pointer here. And we would have looked for the sum 0 plus -1. So first thing first, we would have sorted this list. So because it would have been easy to look for the elements we have been looking for. So because if we the intuition of sorting comes to my brain, because if we have after sorting, we can determine which pointer we can reduce, right? So in this case, since in an unsorted list, we don't know where is the larger element or lower element lies. If, for example, our sum becomes, suppose if we have number 3 and have sum becomes, suppose 4. So we have to decrement our result, right? So how can you decrement it in the unsorted list, right? So in the sorted list, what we can do is let us first sort this array 1, 2, and what we have done is placed our 3 pointers, and these 2 pointers help me to look for the sum of the ith element. So we would have looked -2, sorry, -1 and 2. The sum would be 1, right? So the sum is greater, right? Sum is greater. So what would I have done is I would have simply decremented my k pointer because I have decreased my higher value. So I have came to the 1, right? So again I have checked -1 and 1 is nothing but 0, and 0 is greater than -3. I have again decremented my k, so it has come to 0. So again I have checked -1, 0. It would have gave me -1. And as soon as I decremented it, I get to see that my j and k are at same place, which means there does not exist any pair which can sum up to this -3. So what we have done is we would have incremented my I pointer to here and reset my j pointer. So let me first erase this. Reset my j pointer to here and again k pointer to the very last element. Again, we would have checked it, and in this case, we would have got the result 2, which is greater than 1, right? So -1 is simply less than this 2. So again, we would have decremented our k. So in this time, we have our sum 1, which is quite the opposite of my minus 1. So we can neutralize our minus 1 by 1 and we get to see the result 0, right? So we return true. All right, now let me code this problem. The first thing first, we'll be sorting our array. So we are going till the second last element. Sorry, third last element because our j is always one place higher than my I pointer, as you can see. For for example, the elements like -1, 0, and 1, my I pointer would have been here, and my j pointer would have been here, and k pointer would have been here. So I my I should have gone till this is n is 3, right? N is 3. It should have gone till the very first element, which means I should have gone till the here, because the condition j less than k would not have been satisfied if I have gone any further. So that's why n minus 2. So let us submit. Right, we have messed up something. So expect. Okay, my bad. All right, thank you.